Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we're going to be talking about a problem involving Rolle's theorem. If you have any questions, please leave them in the comments below. And also, if you have any other problems that you'd like to go over, please leave them down there as well. So on with the problem. So today we're asked to state and illustrate Rolle's theorem using f of x equals x to the m times 1 minus x to the n, where m and n are both greater than 0. So Rolle's theorem states this. If f of x is continuous on the closed interval from a to b, and differentiable on the open interval from a to b, and f of a equals f of b, then there exists a c in that open interval from a to b where f prime of c is equal to 0. So what we need to do now is find a place where the derivative of this function is equal to 0. So let's do that. That's going to be the most work in this problem. So we have f of x is equal to x to the m times 1 minus x to the n. So we have a product here, and so we're going to be using the product rule. And if we remember from before, if we have a product of two different functions, so say g of x times h of x, and we want to take the derivative of that, then that is going to be equal to the derivative of the first times the second plus the first times the derivative of the second. Or it could be vice versa, depending on how you were taught it. So for us, our g of x is equal to x to the m. So that makes g prime, well, m is just an integer. So m is just a number. So m is going to come down front, and it's just going to act very much like the power rule. And then we'll take the exponent up here to be m minus 1. So bring the m down front and then subtract 1 from the exponent. And then h is going to be equal to 1 minus x to the n. And the derivative of h, so this will be the power rule at first. So we bring the n down. So n times 1 minus x raised to the n minus 1. Subtract 1 from the exponent. And then multiply this by the derivative of the inside using the chain rule. So now we'll put everything together in the product rule. So f prime is going to be equal to g prime of x times h of x plus g of x times h prime of x. Okay, so now I'm going to rearrange everything here, and I'm also going to think about what factors I have in common between these two terms. So taking everything, just rearranging everything, I get m times x to the m minus 1 times 1 minus x to the n minus n times x to the m times 1 minus x all raised to the n minus 1. So what's in common between these two? Well, in general, when we look for something in common, we look for the factors that have the most exponents in common with each other. So if I had something like ax cubed plus bx to the fourth, well, I know that they both have an x cubed in common, not x to the fourth. So I can take out that x cubed out of both terms. And then if I have more than that in one term, then I leave that there. So the same thing is going to happen with this. When I look at the first term, I have an x to the m minus 1. And then if I look at the second term, I have an x to the m. So I can pull out the smaller of those two powers. I can pull out the x to the m minus 1. I could also pull out a 1 minus x to the something. And again, I want the smallest exponent because I know that that's going to be in common with both terms. And so I can pull out a 1 minus x to the n minus 1. And then what I have left now, so I have left an m. I also have left a 1 minus x. And then from the second term, I have a minus n, and then I have an x to the m as well. and close that off. Okay, so what I want now is I want to figure out where this expression is equal to 0. Well, if I look at each factor individually, I need x to the m minus 1 to equal 0. I need 1 minus x to the n minus 1 to equal 0. And then I also need, for that last term, I need m times 1 minus x minus nx. Made a mistake up there. That m should go away. And then that has to equal 0 as well. So this first term, this first equation, tells me that x has to equal 0. The second equation there tells me that x has to equal 1. And you can verify that by plugging 1 and 0 back into both of those, and indeed you'll get 0. Now for this last one here, I'm going to go ahead and distribute the m into this binomial. So I get m minus mx minus nx equals 0. So I need to solve this for x. So I'm going to move the two x terms over so that they become positive. So I get m is equal to mx plus nx. And then I'm going to divide by, or I'm going to take out an x, divide out the x. So I get m plus n times x. And then the last